First, hello and welcome to the What's New in Spring Integration session. First and foremost, thanks for attending, and how do you enjoy Devnexus so far? Some good talks? Are you burnt out already or on the verge? Okay. Well, what I'd like to do today is basically just, I'm going to have a light session, kind of a end of a conference. What I'd like to do is kind of introduce you to the latest features of Spring Integration 4. How many of you are Spring Integration users to begin with? How many of you have heard or tried Spring Integration users? Again, outside the users themselves. So I'll assume you're a bit familiar with what Spring Integration does. But I'll try to kind of explain things a little bit more detail as we go on. So first and foremost, who am I? I'm working with Pivotal. Pivotal is sponsoring, is actually hiring the Spring teams. I'm working on the Spring XD team. How many of you have heard of Spring XD? Oh, that's good. That's great. If we have time, we're going to talk a little bit about Spring XD at the end of the talk, because it ties pretty nicely into the topic of Spring Integration. I'm a former Spring Integration contributor and co-author of Spring Integration in Action, like the Spring Integration book. I think it's a little bit out of date now, 2 years after, but it's still an interesting read for explaining the main concepts behind the framework. And basically, I've been working mostly on open source software for a long time, and I'm a very big proponent of open source. And it's kind of exciting to be able to work in these types of projects within the Spring framework itself. My focus today is to talk a little bit about, yes, we're going to go through the features of Spring Integration 4. I'm going to talk about them, but I want to put them into a context. I want to talk a little bit about the evolution of the Spring Integration framework and what are the major themes that underpin the latest edition and basically the roadmap for the future. One interesting thing is, after all, what is Spring Integration? Spring Integration is an enterprise integration framework. And one interesting thing that came out in a study made by D-Zone last year, they did a survey and surveyed what are the most popular solutions for performing enterprise integration. Much to our surprise, not to our surprise, enterprise integration frameworks, not standalone ESBs, are more popular than complete runtimes. So people like the lightweight frameworks a little more. To our surprise, though, and it was a pleasant one, Spring Integration came out to be the most popular enterprise integration framework. It was more interesting because we actually had no part in this study at all, so we just saw the results. How did Spring Integration get there? How does Spring Integration evolve? Basically, and this is, I think, to understand the context of the continuous transformation of the framework, it's best to take a look at the ecosystem. How many of you have tried to write an extension, to write a component for Spring Integration? You should. It's actually quite easy. And let me begin by kind of explaining how Spring Integration as an ecosystem is structured. So there is the core Spring Integration framework proper, we call it, which has the core messaging API and the core components. So basically all the abstractions that the rest of the framework builds on. So messages, message headers, channels, and a lot of other things like message stores, for example, for operations like aggregation, metadata stores for storing metadata, and we're going to talk about that in a bit. And on top of all that, we actually have the enterprise integration patterns. So things like a filter, things like a splitter, things like an aggregator. Outside of that, like those are all let's say pure, just simple pattern implementations. Outside of that, you have the actual integrations. So file, JDBC, Redis, Rabbit, there's a whole lot of them that you can find in documentation. These are the very established, very stable, let's say, external technology integrations. Then there are some, then come the Spring integration extensions at the other extreme. These are new, basically new contributions. Someone, for example, needed to create a channel adapter that connects to, let's say, AWS, right? Wanted to write a message store that stores messages in DynamoDB. And they did that for their own project, and they wanted to contribute them to the community. So these types of things live in the Spring Integration Extensions project. And as they mature, as someone actually takes responsibility for maintaining them, as for example, as their APIs become more and more established, they actually migrate towards the core framework proper. And a few frameworks have actually taken the leap like that. MQTT, that we're going to talk a little bit later, has taken the road. So if you're looking, for example, at writing your own components, Spring Integration Extensions is a great place to start. It's also a great place to actually look at what future changes are coming, because people contribute to that. In between are projects which are promoted out of the extensions repository and have a life of their own. Like, for example, Splunk. There is a Splunk integration. How many of you are using Splunk? I've heard of it. Right. Okay. So there is, for example, a Splunk project that has channel adapters for Splunk. How many of you have used or heard of Kafka? Apache Kafka. The Apache Kafka, for example, extension has just moved from the extensions repository into a project of its own, and it's on the way for being migrated to like a core fundamental extension. So this is basically just to give you a little bit of a context of what we're going to discuss next and where the changes actually take place. In terms of history, like in terms of history of the framework, we're going to talk about releases 3 and 4. How many of you, like, what versions of Spring Integration are you using? How many of you are using Spring Integration 4 already? One person. How many are using Spring Integration 2? How many people are using Spring Integration 3? One person. How many are using Spring Integration 2? No one. How many are using Spring Integration 1? I swear I saw more hands when I asked who is using Spring Integration. Anyhow, basically, the framework itself has been in a continuous evolution, partly because it tried to define itself and try to find what's the best way of doing things, partly because it's undergoing, as I said, a transformation from being an enterprise integration framework to kind of address other concerns, right? So version 1 basically has tried to define the core components, the core enterprise integration patterns, and had some integrations, like the most, I'd say the most sought after, XML file and so on and so forth. Spring Integration 2 added Spring 3 and spell support. Added more integration patterns to the mix, more integrations. This is when things like JDBC come into place, or TCP, or other endpoints. And added some enhanced namespace and annotation support. Releases 3 and 4 actually came out very, very fast. So I wouldn't be surprised if, for example, you skipped release 3, because release 3 was basically the last one that supported Spring Framework 3 and was released in October 2013. throughout 2014, we got 4.0 and 4.1, and release 4.2 is forthcoming. So there is a very rapid succession of changes that happens in the framework itself, and new things are being added. And basically what I'm going to go today through is what these changes are and what are the major themes, and how does the framework actually evolve. Like, what are the major directions that the framework is heading to. First is architectural consolidation and internal refactoring. So that was a big change in Spring Integration 4. Basically, everything, like the whole core messaging API. And it's going to be I know it looks a little bit dry to list all these classes on the slide, but I did it deliberately to get an understanding of what was the natures of things that have been moved around. Like, if you're familiar with Spring Integration, you'll recognize most of the core classes, messages, channels. Everything has basically has been basically pulled up into Spring Core. Of course, that required an internal refactoring in Spring Integration, so that it actually so that basically can work with all these classes right now. Why did it happen? Well, the messaging abstractions and the messaging paradigm that Spring Integration actually did very well applied to other things that are not necessarily connected to Spring Integration, not directly. In particular, and that was the major driver, WebSockets. So the implementation, like Spring Core 4 has a WebSockets implementation. It has messaging support over WebSockets, so WebSocket messaging. It has support for Stomp. It has support for SockJS. All these are messaging protocols over the web. So it didn't make really much sense to have the dependency through Spring Integration itself. So basically what happened was that all these APIs were pulled up into the core framework. The net benefit, however, is that right now you can write an extension that handles the concept of a message without depending on Spring Integration directly. You can write a message handler, you can have a message channel. So if you want, for example, to write a message handler, for example, and inject it into an outbound channel adapter, you can do it by just implementing it against the core Spring framework. The Spring Integration understands messages basically created by against the core messaging API itself. So that is actually a huge benefit for the framework itself. On the other side, the new releases have focused. So let's start with the new additions, more in terms of what features have been added, like at the more abstract level. And basically, some of the new additions were new integration patterns. For a long time, we wanted to do scatter-gather as a standalone programming unit. What's scatter-gather? Basically, it's a pattern where a request is broadcasted to multiple handlers, and then at the end, a component basically tallies the responses and produces an answer based on them. It's something you could implement, right? Like, you could have implemented this very not easily, I would say, with a publish-subscribe channel or a router. Had it and an aggregator at the end. It's just that it requires writing a lot of code. So basically, what happened was that we created this distinct scatter-gather component. You have an example here. Basically, for a scenario where we want to find out the best quote from 3 vendors. So the message comes in, it's broadcasted, you see the scatter component there, basically scattering effectively the messages to the 3 separate channels, vendor A, vendor B, vendor C. And then internally, the component creates a channel for the responses that are sent to the aggregator, and the aggregator uses this is a very simplified definition. Basically, the gatherer is nothing more than an aggregator that has a reference to an aggregator bean and computes the final result based on the responses from all 3 vendors. So that's one way we actually kind of simplified the way you write Spring integration applications. Another pattern that has been added to Spring Integration 4 is routing slip. So routing slip is a way of routing messages to different components. It's possible to do it dynamically or statically, any way you want, without actually wiring them. So previously, if you wanted to send, for example, a message from processor A, B, and C, you actually had to connect them through input and output channels, which is great. But sometimes you don't want, you want the route that a message takes across the different services to be dynamic, to be decided at runtime. So this is where the routing slip comes on. My example actually uses, let's say, a static list of channels, but the component itself takes arguments such as spell expressions. So you can actually have the target channels computed based on the content of the message, or it can take even a bean that computes the list of channels that the message has to be sent to. So it's actually a very, very flexible way of dispatching and basically creating a route for a message throughout the framework. The third pattern that has been added, and for which we have added support, is idempotent receiver. Basically, what happens is, in scenarios where you have support for retry, you can't always decide whether, very often it happens that you are too conservative. You can't tell whether a message has been processed or not if you haven't received a confirmation. So there are very specific scenarios where you want a message to be processed only once and make sure that it's processed only once. The way this has previously been done, it was possible to do it with a filter and writing a custom filter that had that basically did some filtering based on by monitoring the messages that have been processed. But in fact, it's a very good idea to have a dedicated component for that. So we have an idempotent receiver that basically acts as an interceptor for an endpoint. Keeps track of what messages have been processed in a metadata store. And this is, for example, this is an interesting example that I will come back a little bit later. And basically what I can configure there is things like, what's the key for that message? How do I decide that that particular, how do I uniquely identify messages that have been processed in order to decide whether they have been processed or not? So I can have this as an expression. I can have references. There is a large variety of ways of configuring this particular component, but the idea remains the same. You want to have the key. You want to have the store. You have to have ways to produce it. that's basically one way of simplifying things by creating new components that implement well-established integration patterns. The other way in which Spring integration actually sought to simplify the developer's work is by adding more support for Java, like for defining and declaring components directly in Java. So one way one way it actually did this is by enhancing the set of annotations for configuring endpoints. As you know, in Spring integration, you can declare your components using XML, but you can also specify, for example, if a specific method is a transformer, or it's a splitter, or what it is. And it's going to be wired accordingly in the bean definition. So basically, we added some new ones for the message gateway. The gateway is, again, is a component we're going to get back later, is a component that transforms the normally asynchronous interaction model with Spring integration, right? You just fire a message and send it on a channel and it's gone, into a synchronous one. So really implements a request reply paradigm for your components. The global channel, you can define global channel interceptors, converters, folders. Essentially, I listed all them here just to get to give you an idea of what's available there. You can get to the details there. I'm just trying to get a little bit of context for this. The other direction that Java support went in Spring Integration 4 was providing support for Java configuration. So the ones that are using Spring Integration already. How many of you using XML? How many of you using Java? XML first. Java? No one. You should give it a, depends, like XML has the nice feature that after all it makes for a pretty nice DSL. At the same time, as you will see, obviously Java is pure code. We have a fluid API for defining integration flows, so you may want to take a look at it. Basically, how many of you are familiar with Spring's at configuration annotations? So basically, Spring provides a way. Let me just show you a bit of code here. Let me just. Let me just pull up a class and show you that. So Spring allows you to declare to create context configurations which are completely written in Java. So the way you do it, you create a class annotated with at configuration. Maybe I have an example. Like this is a very, very simplified one. I think I have a couple here. Yeah, so here's an example. So you can have a class that has that basically is annotated with configuration and has method annotated with @bean. So when Spring processes such a class, it creates really an application context in which the result of invoking these methods is basically treated as a bean. And in particular for Spring integration, this means that we can actually go and instead of creating the XML for defining the message channel and so on and so forth, we can create methods like this. Like this declares a message channel named foo. We can create other beans, for example. This is an example of the transformer annotation applied to a bean. So this definition creates a bean that's a transformer, has an input channel named foo. And we can go actually, we can go quite long with this kind of thing. I just wanted to give you a hint of what these annotations are. Basically, they allow you to write your context definitions completely in Java. And the other things that they do is they simplify things like, for example, integration component scan is essentially the equivalent of the Spring Integration component scan, XML. So you don't have to have that. Other beans create post-processors, for example, the mbean export. Others create bridges, so have semantic functions like that. On top of all that, we've added, like, Spring Boot has added support for Spring integration. So you can basically create a Spring Boot application that is nothing more than a Spring integration context definition. That is a very, very important. Very important addition if you want to create modular integration applications. Because one of the problems that you have, like when you have an app that doesn't run in an application server, is, well, it's all good, but I have to create the instantiate the context, I have to do all this work. Right now, everything is basically taken over by Spring Boot. So it is in fact very simple to create, and that, I'm going back to the example before. It's actually very, very simple to create this this application that's very, very compact. So this is basically an entire integration module that takes a message from a channel foo, transforms it, and sends it to channel called bar. Actually, there are two transformers changed, sorry. So the listener to the bar channel actually sends it to, takes the message processed by the message handler here and uppercases it. So if I'm running this example, you will see in a very, very simple way of actually, well, it's kind of a very, very limited use case, but you can see the message that's actually being sent here to the gateway here being returned, transformed. So everything that happened here was a Spring integration, is a Spring integration context. Even like pushing things at another level, yes, it's nice that we can actually declare all the channels separately. We declare them as Java objects. We declare them as Java beans. We've done all that. But we like to skip, for example, we may not like the idea that you have to put all those channel definitions in place and you have to change them manually and so on. So this is why we created this Spring Integration Java DSL. So basically, if I want to describe the same use case as before, I have this flow that says, well, starting from channel foo, listen to channel foo, and then create a transformer with this spell expression, handle the payload with this lambda. How many of you are using Java 8 already, or have tried using it? How do you feel about Java 8 versus Java 7?
It's like a different language.
Completely different language?
Might as well be.
Yes, I mean, I like the lambdas, and I like the lambda support just because it allows writing, first, it allows writing things like this in the language itself. Second, because it treats the handling, for example, of these, anonymous inner classes more efficiently. So it's not only nice from a like visually, it's also it's also more efficient at execution. Anyhow, this is one example. Normally, like if you don't have to use Java 8 to use the integration flow. You can simply pass in a method, like you can pass in a method that actually performs this particular transformation, like takes the payload and the headers and does the transformation itself. But that is the flow, so it's much more simplified. A lot of effort has gone into the direction of actually making things more simple. For the, like at the other end, it's fine. Like right now you can write very simple context, everything goes okay. What else is a problem in this case? What is not to like about what we just did? I mean, it's cool that we have a gateway. It's cool that we have the gateway connected to a channel. It's cool that we have hidden behind an interface. We can send a message, get a response. We're completely agnostic of the processing that happens there. What's not very cool about it is that I have to either block waiting for the response, or in previous versions of the framework, you could have returned a future. And returning a future is better than blocking, but not by much. So basically, in Spring Integration 4, we added support for this listenable future, which is actually an abstraction introduced by the Spring Core framework. What it is, it's pretty much what its name says. It's a future that has a callback that can be executed when the gateway returns. So basically, when the invocation of the gateway comes back, we will get this. We will get either a call on success or on failure. What's good about it is that you can fire the message, register the callback, and continue your processing. And in your callback, you actually get you will get invoked when the method has finished. So that's a first step towards reactive programming, actually, in with Spring integration. Another feature that's been added in terms of support is support for promise. Promise is a class provided by another Spring project called Reactor. How many of you have heard of Reactor or have used it? Cool. So Reactor is a project that has been designed exactly with the goal of promoting reactive programming, and has one of the things that it has is support, for example, for streaming. And by streaming, I don't mean necessarily Java 8 streaming. I mean streaming more in the sense of reactive streams. And in fact, version 2 of Project Reactor has a reactive streams implementation in it. So basically, what can you do with this is you can register a promise. You can return a promise. Now that sounds pretty cool. Like, are you familiar with the promise programming model, or have you encountered it in other languages? Or it's been implemented a few times. In this particular case, what it means that the result is is basically a component that emits one value, which is the result of this particular operation. Like basically, by sending data to the gateway channel and waiting for the Spring integration context to process it. What is cool about it is that you can actually register it in a stream processing definition. So I can say, well, at this point in the processing chain, like I'm taking this array for example, I'm mapping it, like I'm returning and transforming it to integers, and then I'm going to invoke multiply by 2 in this, like by sending data to the gateway, and because the result is a promise, it can actually be integrated in the entire stream. So the takeaway from that is, like, even if you're not familiar with a model, even if you're familiar with Reactor, even if you're not familiar with a lot of things that are on this slide, but one takeaway is support for, like, this, the gateway support in Spring Integration 4 has evolved beyond simple method, like simple mimicking a method invocation. It has evolved towards asynchronous programming. It has evolved towards stream processing. The other direction that Spring Integration 4 has gone into is distributed processing. So, up until version 2, for example, there were abstractions that allowed, like, actually, let me put it other ways. Spring Integration as a framework is built a lot on the notion of abstraction. You can create your own type of channel. You can even generate your own type of message. You can create your own adapters. A particular component in this case is, for example, the metadata store that I mentioned before. Remember when we talked about the idempotent receiver, or a file processor that, for example, creates a message whenever a file has been added to a directory. Now that component has to keep track of what files have been processed so far. Otherwise, every time I'm starting every time I will stop and restart the application context, I will get the whole data processed again and again. So one of these pluggable, the pluggable component that maintains state for Spring Integration components is the metadata store. And up until version 3, the metadata stores were one that was available in memory and one that was backed by a property file, which is not very efficient, but has another problem. If I have multiple components listening, like working at the same time, they might as well end up seeing a different copy of the state that's being stored. So we needed support for a metadata store that can actually operate in a cluster of Spring Integration components. There are actually 2 implementations available added. There is one backed by Redis. How many are using Redis or heard of it? Or cool. The other one is based on Gemfire. Any Gemfire users? Cool. So essentially, what it does, it's storing data in a data grid. And in fact, there are a few, because the model is so extensible, there have been people trying to create, for example, other stores, like using Hazelcast or anything like that. Like anything that can store data and can be distributed and can operate like basically in like a distributed data store, so to speak, is a candidate for this. The other abstraction that we have an implementation for distributed scenarios is the lock registry. So what happens is, when you have components such as aggregators, resequencers, and anything that relies on correlating messages, they actually store, they have to store data in a single place, but they have to coordinate between themselves. For example, you don't want to, first, you don't necessarily want aggregators to store data locally because they might crash. So distributing that kind of data is a good idea. However, if you have 2 aggregators operating off the same set of data, you don't want them to basically trip over each other. So there has to be some coordination. There has to be access to, there has to be a way to coordinate to accessing the critical section where a message, for example, is added to the aggregation store. So that's what the lock registry is doing. is basically a lock, is an abstraction that allows you to have different lock implementations. The lock that I'm talking about is really a Java lock, but is backed by a distributed implementation. So Spring Integration 4.0 has added support for Redis and Gemfire for distributed locks. And right now, like there is a candidate for Zookeeper, for example, for being added in 4.2. How many of you are using Zookeeper directly or indirectly? So Zookeeper is a distributed processing coordination environment, so to speak. It's a distributed data store, but it has other abilities such as locking. There are patterns implemented on top of it for leader election. So essentially, a lot of kinds of problems that you have to solve in a distributed environment are solved in Zookeeper. And we're actually using that for implementing these lock registries. Another direction that we've been going towards is Internet of Things. I'm sure you've heard of it, maybe too much. Right. It's modern. It's a new topic. It's important. So what did Spring Integration 4 do to actually support that? First, probably one of the most common. It's not necessarily associated with Internet of Things, but it's definitely one protocol that comes into discussion when you start talking about mobile devices, especially in web scenarios, is WebSockets. Now, here we were a little lucky because Spring Framework already has support for WebSockets as an implementation. However, what Spring Integration provides is actually built on top of that with the abstractions that allow you to build integration scenarios. So channel adapters for inbound and outbound, like for basically receiving and sending messages over WebSockets. And there is also, for example, a way to create gateways and create request reply scenarios using WebSockets in Spring Integration 4. In a more, let's say, hardcore mode is MQTT. How many of you have heard or used MQTT? You will. It's a very so MQTT is basically a protocol designed for I think MQ telemetry transport, but I'm not sure about the last T. Anyhow, telemetry is the keyword here. It's designed for collecting data from a large number of devices. It's exactly the type of scenario where you have, for example, a large fleet of vehicles that have to report status home. It's not designed for large packet sizes, so it's small messages, but very, very frequent, and usually in a hub and spoke type of scenario. So you basically have a server or a number of servers, they basically have one central endpoint where all your connected devices report to. Again, what Spring Integration did in this case is provide support for creating a server and for listening to these incoming messages. It's essentially like the main mode of use of MQTT is inbound, and basically creating a channel adapter where you can process messages that are sent by your sensors and devices over MQTT. Other directions that we went into are data streaming. So Spring Integration was always a message-driven, framework, has always had integration with messaging middleware like JMS, Rabbit are the most typical ones. Even Redis message queues. what we added is a new component for Kafka. Again, Kafka is a very, let's say, new, maybe not very new. It's been around for a while, but has gathered a lot of attention in the in the past couple of years. It's a messaging system that kind of it's a distributed messaging system that works as a high-performance messaging platform, essentially applying the paradigm of a distributed commit log. What does that mean? It basically means that messages are just written in topics, in logs. It relies on the high performance writes when you actually like high performance of linear writes, so messages are always written at the end of the topic. It doesn't keep track the server itself doesn't keep track of how far the consumers are. Consumers are themselves responsible for looking like at a topic or partition and figuring out where they want to consume from. And one of the things that is interesting is that data is highly partitioned between the different brokers for both failover and for performance. So basically, you can have a consumer listening from one broker to one partition, and consumer listening to another broker on another partition, and so on. With Kafka, what we did was say, well, we understand the model, we understand the log model of Kafka, and what we would like to do is apply the same paradigms as we have for the Spring framework. So basically, the ability of doing event-driven message processing as well as production. So we have a producer channel adapter for Kafka, and then we have an event-driven channel adapter that listens to different topics. And one of the major things that we did with it, and again, remember that if you ever hear about Kafka, is that somehow, I wouldn't necessarily say unique, but very specific to Spring, to Spring integration Kafka, was rewriting the entire infrastructure so that it uses the simple consumer API, so that we have control over, for example, how do you progress during the while you're actually consuming for a topic. We actually allow you to decide where to store your offsets. We actually allow you to control over what partitions you listen, so you can actually distribute your work any way you want. And all the while, we actually provide concurrency while preserving a very, very important contract, which is that all the messages from a given partition are consumed exactly in the order that they have been written. So this is basically the definition of a Kafka message-driven channel adapter. There are some very Kafka-specific things in there. The takeaway is that we've applied this, we've taken the Kafka model and applied the Spring integration processing model to it while preserving the specific of the underlying middleware. Those are, let's say, major themes of Spring integration 4. They're not the only ones. But I think there are the ones that are that I found very relevant and very very telling on the directions that the framework is heading towards. So what I'm going to do next, what I like to do let me do this. Let me tell you a little bit about the future of Spring Point 2, and then I'll cue to the Spring XD. So to stay on the topic of Spring XD, of Spring integration, here's what we would want to do next. Basically, it's already done. In fact, it's in the 4.2 trunk already, is the rework of JMX monitoring and management for performance. So basically, we recognize that certain things that we've done in earlier versions of the frameworks with the requirements of that particular time would be better, addressed in in the context of a, for example, much higher message rate with certain improvements. So yes, we actually went in and said, well, there are better ways of doing this. So we have a much more performant monitoring and management support in JMX. Other things that we are looking at are support for AWS based on the Spring Cloud AWS project. So essentially you can create, you would be able to kind of use all the AWS components with Spring integration adapters. Obviously, we have implanted more adapters based on Spring Data support. As you've seen, as I mentioned, for example, just to give you a hint, right? Some very basic stuff like let's see. Small resolution is always so confusing. So it's, for example, and this is something that just came through, support for Hazelcast. This is a PR that's just being opened right now. So things are in motion, and we're adding, there's a Spring Data, for example, has a lot of support for different integration with different technologies, and we are adding more and more support based on that. Of course, enhancements to Kafka, support for as you've seen, we actually did some work towards a better support for asynchronous programming, but that doesn't stop here. More support for reactive programming, which is another new and modern topic, will be added. If not in 4.2, it definitely will be added. It's on our roadmap. As you've seen, releases, new releases are coming very, very often, and we evolve. The other part that I wanted to talk about and touch a little bit, because I think it's very relevant. It's not necessarily about Spring integration itself, but it's important in the context of Spring XD because it's so intimately connected to it, is Spring XD. So again, Spring XD, and I understand that some of you have already tried. Once again, I'm sorry, I didn't remember. How many of you have tried Spring XD? One person. Basically, what does Spring XD do? Spring XD in a nutshell is a high performance data processing platform built on top of Spring components. It's basically recognizing a few problems, like batch, you have different types of, in the data processing space, you have different types of problems like batch processing, stream processing. They're usually handled by multiple platforms, by different solutions. You have different implementations to do each. The ecosystem is very fragmented. If you look if you look around, it's basically a very disparate set of tools put together to actually try to address a particular type of problem. And basically, you have this kind of a very flashy, shiny thing here, which says, well, what it is, but it's actually true. It's the one-stop shop for developing and deploying big data applications. I'm going to show you very quickly one example. But first, in a nutshell, XD stands for extreme data. Extreme data means that it's really, like its target is, as I said, high volume data processing. It is, essentially, it has support for use cases such as data ingestion, like really moving data from, let's say, you're receiving data from MQTT, for example, and you want to store it into HDFS. Real-time analytics. You want, like, you not only want to ingest your data, you not only want to open a number of endpoints that your sensors can actually talk to, like send data, as I said, HTTP, WebSockets, MQTT, whatever, in real time. But you also want, for example, to do some calculation on that data in real time. You want to count how many of X is there, how many, you have batch processing, right? Not only, like sometimes you ingested the data, you want to execute it. You want to run a batch process on top of it. You want to extract data from from your stores. So essentially, SpringXD tries to address all these concerns. And the cool part of it is that while it's a new project in and by itself, it's built on very well tried and tested solutions. So it has basically all the power of the Spring framework behind it. It has like the whole core, boot, data, the entire platform. And obviously it builds on top of Spring integration and Spring Batch as its foundational components for handling the two concerns of connecting distributed components and basically running batch processes. So how does stream processing happen in Spring XD is you essentially define these streams. Stream processing is essentially the context where the link with Spring integration is the most obvious. Basically, a stream in Spring XD is a source, right? Like a source emitting data, traveling through a number of processing steps. We have one, but we can have more, and basically being written to an output sink. And you have as many sources as you have basically as you have integrations with Spring integration, so to speak. There are a number of pre-written transformers, and as well, there are a number of predefined sinks, all of them based on, again, all of them based on the Spring integration support. The whole processing in Spring XD happens in a distributed runtime. So imagine that you have a number of components and you want to distribute them and you want to write and connect them. You can do it manually, like you can have all of them, for example, read and write to a RabbitQ, and you can do all that stuff all by yourself, and you will end up with a distributed system. Basically, what happens is that Spring XD allows you to define these components and runs them for you. So it has, it's basically, obviously, like any distributed system, it has to have some central coordination, which is the admin node. And it has a number of containers where the different modules execute. And Spring XD connects them through an abstraction called the message bus. Now, the connection with Spring integration should be apparent at this point, because really the message bus is really based on Spring integration channels. Modules are basically Spring integration contexts. Each module essentially communicates, like has by convention, one or two channels, like either input and output, or only input and only output, depending on what they are, a processor, a source, or respectively a sink. But the biggest benefit here is that you can essentially take any Spring integration component that kind of abides by the convention that it has a input channel, output channel, or both, and turn it into one module. And then you can build and connect them together in streams. And if you do that, then you really have the you really can handle other concerns such as concurrency, for example, scaling, failover, and leave that to the runtime itself. The other thing is, as I said, most Spring XD integrations, so most Spring XD sources are literally built, literally built on top of the, like by reusing the existing Spring integrations. You name it. And most of the time when we actually have to extend the framework, we actually create based on extending Spring integration itself. So it actually taps into the richness that Spring integration has to offer and adds a very solid runtime underneath it. And the way I say it is, yes, we call it Spring XD because it's pursuing extreme data, but conceptually, you can think about it as your runtime for your integration solution. There is no penalty to pay for that. It works very well, like it scales very well, up, but also down. Let me show you. Let me open up, let me just show you a very quick. Let me show you how simple it is to create a stream that basically processes data coming in every second, so to speak. I've started Spring integration, as I told you, Spring XD. Spring XD, as I told you, is a runtime, so it's, let's say, its own application server, so to speak. It's probably something that I shouldn't say again. It's not exactly correct to call it application server. It's a runtime, right? I started it in single node mode, which means that it's a more compact version. So all the nodes, administrator, container, and everything there are together in a single runtime. Normally, in a production environment, you would start it in a distributed mode. And then I started the shell. And now I'm going to connect to the server, right? And what I'm going to do is I'm going to create a stream of data that basically emits one message every second with the current time and logs it. And that was all. Of course, it's a very simple, very basic example, but it illustrates a few points. One, that it shows you how easy it is to create a stream. Stream definitions themselves don't get more complicated. Like, okay, they can get more elements into it, but they don't get more complicated than that. It's just a matter of chaining elements together. And they're all, like, if you can describe, for example, your solution in terms of a processing chain, you can actually use something like this very well for your integration solution too. And obviously, if you have a big data solution, then if you want to create a high performance, high volume stream, then definitely XD is for you. So that kind of concludes that kind of concludes my tangent on Spring XD. I know this was a Spring integration topic, but both as a Spring XD team member and both as a Spring integration user and contributor, I don't feel that right now at this moment. Like, I think that Spring XD is also an integral part of the Spring integration story. So kind of wanted to share that. That's all I have. As you see, as a conclusion, Spring integration is evolving, is evolving in a lot of directions. In general, the directions are dictated by two factors, or dictate, like, it's always trying to keep up with the times. You've seen some very modern themes addressed, like Internet of Things, data streaming, is dictated by community. You've seen a community contribution right now, like just enhancing the functionality by adding hassle cost because somebody felt that they needed it and they wanted to contribute it back. And you know, keep using it, keep trying it. It's always evolving. Keep in touch. Questions? Then I thank you for attending. And hope you have a great time and a safe trip back.